Hello everyone, my name is Piyush Arora and I'm glad to have this opportunity to present our work on hybrid sample synthesis based debiasing of classifier in limited data setting, supervised by Dr. Pratik Mazumder. In the realm of training deep neural networks, biases embedded in large label datasets pose significant challenges. These biases stemming from data collection methods, annotative subjectivity, and other sources adversely affect model predictions. Deep learning models, in particular, are highly susceptible to these biases, leading to skewed predictions and diminished performance. Conventional debiasing approaches often rely on prior knowledge of biases and impractical assumption due to the unavailability of labeled data indicating biases. Some methods intentionally amplify biases in one network, attempting to debias another by focusing on bias conflicting samples through techniques like loss reweighting. In real world scenarios, with limited label data, such as those dictated by privacy, connectivity, or cost constraints, these conventional methods fall short. Moreover, the vulnerability to overfitting in limiting data settings, particularly to bias aligned samples, underscores the need for innovative solutions. Addressing these challenges, our promising approach involves identifying bias conflicting samples in the training data and synthesizing hybrid samples that incorporate both bias conflicting and bias aligned property. These synthesis aims to reduce the impact of bias aligned samples, preventing overfitting and guiding the model to focus on interesting features rather than superficial biases. Furthermore, employing loss reweighting ensures that the model prioritizes learning from bias conflicting samples, enhancing its resilience against dataset biases. So, the problem setting. So, first of all, for the experimental setup, we have the training dataset D, which consists of limiting training data. Data is obtained by randomly sampling p% of the training data for each class from a biased training dataset. We don't assume any prior information about the bias in this work. We first of all define bias aligned samples as samples that exhibit a high correlation between bias attributes and target labels. Contrary to it, bias conflicting samples occur less frequently and lack correlation with the bias commonly associated with that sample type. Bias conflicting ratio represents the proportion of bias conflicting samples in the training data. The objective of the experiments are to reduce the impact of bias on model prediction, and this reduction must occur when the model is trained on limiting training data containing bias and there is no access to prior knowledge about the type of bias affecting the data. So this is an overview of our approach and an extended detail of which can be found in the research paper. So the first component is dual model training, which has been inspired by learning from failure paper published in Europe 2020. It involves parallel training in which model MB and MD are the two models with similar architectures. Trained simultaneously, MB is intentionally biased while MD is designed to focus on bias conflicting samples that MB finds challenging due to incorporated bias. To train MB, generalized cross entropy is incorporated, which gives more importance to training data points with high similarity with the model predictions and labels. Objective of MD involves training it on to focus it on bias conflicting samples that are difficult for MB to learn due to its bias. Loss reweighting for MD. A reweighting factor Rx is calculated using the cross entropy losses incurred by MB and MD for a training data point X with label Y as shown in the following equation. So Rx is equal to LBX divided by summation of LBX and LDX, where LBX and LDX represent the losses incurred by MB and ND respectively. This reweighting is then applied to MD by simply multiplying this reweighting factor with the losses. Hybrid sample synthesis. First of all, it involves the identification of bias conflicting samples using a threshold PC. High reweighting factors indicate samples challenging for the bias model to learn, suggesting potential bias conflicts. Hybrid sample synthesis involves creating a hybrid training data by combining likely bias conflicting samples with likely bias aligned samples from the same class. The goal is to increase the bias conflicting samples and mean diversity. The equation for the hybrid sample synthesis can be seen below, in which we have a hyperparameter alpha controlling the sample contribution. The reweighting is done similarly as we have done in the previous dual model training. The final loss for MD can be seen as the loss which was involved in the dual model training plus the loss cross entropy loss involved for the hybrid samples. Beta hyperparameter helps us in controlling the amount of loss that we want to backpropagate. As we can see in the results, our method clearly beats other methods available, including learning from failure, learning debiased distant angle representations, and DebiAN. Furthermore, the results can be seen even on the corrupted CIFAR datasets that our method outperforms the other ones. Similar performance can be seen even on the biased FFHQ dataset. Thank you.